Hello students, welcome back. Today we'll continue with the 18th video lecture of chapter number 9, that is ray optics and optical instrument. In our last video lecture we have studied till simple microscope. Now today we'll study about compound microscope. Okay, so now in our last video lecture what we studied, that magnification, the formula for magnification of simple microscope. What is simple microscope? When we are using a single convex lens, M was equal to D by F. So, if we want to increase the magnification, we must reduce the focal length. Right? Now, as we are decreasing the focal length, the lens is becoming thicker and thicker and thicker, right? And also a simple convex lens or a simple microscope can give a magnification maximum to 20x, means 20 times, right? But if I want still higher magnification, then what should I do? I can take another convex lens, right? Means the image formed by one convex lens, let's take it is the magnified image. Now when I'm using that image as object for other convex lens, it will still magnify, right? That is the principle of compound microscope. Compound microscope take use of two convex lens. The image formed by one convex lens, I will say magnified image formed by one first convex lens, act as object for second convex lens, and it will still magnify it higher. Okay, so this is the schematic diagram of the two lenses, arrangement of two lenses in the compound microscope. Okay, now let's see here. One of the lens that is called objective, that is smaller in size. Okay, and the lens that is kept near the eye, means from which we are observing, that is called eyepiece. The eyepiece is larger in size, means it is having higher size, and objective is smaller in size. Right? See what you can see here, the object AB having height h0. When it is placed in front of convex lens, an image is formed here. See, this Q is the focal point of eyepiece, P is the focal point of objective. So image is somewhat formed near the focal point of eyepiece. See, this is the size of object and size of image. So this is magnified image. Now this image acts as an object for this eyepiece. So again it will magnify, right? So here now this lens acts as simple microscope and the image is from the same side, right? Where D is the image distance from the eyepiece. Okay, clear? So now to find out the magnification of compound microscope, we will first find out the magnification of objective, then the magnification of eyepiece, and remember the combination of lens. When two lenses are used, the magnification is the product of magnification of both the lenses. So it's M1 into M2. In this case, I will take MO into ME. So first, let's take objective, objective lens. What is the magnification? Height of image upon height of object. This is the simple formula, right? Now see, I am taking two triangles. Okay, see this angle I am taking beta, this will be also beta, vertical opposite angle. I am taking first this triangle. So what is tan beta? Adjacent, sorry, opposite upon adjacent. So this is angle beta, opposite HI upon PB, means HI upon what is this PB? It's near to L. Okay, now what is L? L is the tube length, right? The distance between the focal point of objective and focal point of eyepiece. That is tube length, right? Here you can see that image formed by the object is very close to the focal point of eyepiece. So I'm just neglecting this very small size. It's negligible. So I'm taking this as L. Right here, U is the object distance, F0 focal length of objective, L tube length, Fe focal length of eyepiece, and D is the image distance. Okay, so now see here, this distance L, HI. So opposite upon adjacent HI by L. So what is HI? L tan beta. Clear? Now let's take this triangle. This is also similar to HO, so this will be also HO. Right? Let me write down HO. Okay. Okay. HO. So now here tan beta, this angle is beta. So tan beta opposite means HO upon this. What is this? Focal length of objective. So what does this means? HO is equal to F0 tan beta. Clear? So now magnification, let me write down MO of objective will be HI, that is L tan beta upon FO tan beta. Tan beta gets cancelled, it will be L upon FO. Name this as 1. Magnification of objective length. Clear? Now let's take eyepiece. Now for eyepiece, this acts as this image formed by objective lens acts as object for the eyepiece. Now in this case, it just behaves like a simple microscope, right? If this is the object cap and only one lens we are considering, this is a simple microscope. So we will use the formula for magnification of simple microscope. So magnification of eyepiece is equal to D by F. Clear? So what is the magnification of compound microscope? M E into M O. That is equal to, or one and the same thing, M O into M E. That is equal to L. That implies magnification L by F0 into D by. Now see, ME, this is the eyepiece of for focal length of eyepiece. So it's FE. This is the formula for magnification by compound microscope. Okay, so this was about compound microscope. I'm repeating why when we are using simple microscope, this is the formula for magnification. So to magnify at a larger extent, we used to decrease the focal length. As we are decreasing the focal length, the lens becomes thicker and thicker. Maximum it can magnify, the simple microscope can magnify up to 20x time, 20 times. So we can use another convex lens. Clear? So this place near object is objective. Near the eye is called eyepiece. AB is the object. Image formed by objective is A dash B dash. That acts as object for eyepiece. And this image is formed at this way. This is the magnified and I will say enlarged image, right? So first we found out the magnification of objective lens, that is L by F0. Then for eyepiece, that is D by Fe. So using the formula for combination of lens, magnification of compound microscope will be MO into ME, that is L by F0 into D by Fe. This is the formula for magnification of compound microscope. Okay, so note down this derivation. The next is astronomical telescope. Okay, this is the last topic of this chapter. Okay, in optical instruments, we have studied first simple microscope, then compound microscope, and this is the last astronomical telescope. The use of astronomical telescope is to observe the celestial objects. Now see, the image formed by astronomical is not magnified compared to the object, but it is magnified compared to the object seen by naked eye. Right? Means when you're viewing an object, let's say you're observing a star, right? When you observe with naked eye, you will observe just like a point. But when you will observe it using a telescope, you will get a larger view. Means see, we are not getting a image size higher than the object size, but the image size is higher than that is observed by naked eye. Okay, so that is the use of telescope. Again, here we are using two convex lens, right? One objective, second kept near eye from which we are visualizing is eyepiece. Now, in telescope, it is opposite to that of compound microscope. In compound microscope, eyepiece was having higher size compared to objective. Here, objective lenses have higher size compared to eyepiece. So eyepiece is in smaller size compared to objective, right? So now see, when rays are coming from far away, okay, they will be like parallel rays, right? You can see here these parallel rays are coming. So after the first refraction to objective lens, its image here it is formed A dash B dash, right? Now this image formed by the objective lens acts as an object for the eyepiece, right? And this eyepiece will obtain a magnified image compared to A dash B dash. That is, sorry, A1 B1 and it will be A2 B2. You can see here highly magnified image. So this is the working of telescope, right? What when parallel rays enter to the objective, an image is formed A1 B1. Okay, the image will be formed at the focal end of the eyepiece near to that, and then this eyepiece will magnify the image A dash B dash A1 B1 to A2 B2 because this is acting as object and this will be the image. Clear? So you will observe a magnified image of this. Now, magnification of astronomical telescope, that will be angle subtended by eyepiece to the angle subtended by objective. Okay, magnification. See, I am writing the formula for magnification. Angle subtended by eyepiece to the angle subtended by objective. Clear? So here it will be what is the angle subtended? I am taking here as beta and here as alpha. This will be equal to beta upon alpha. Now see, when I take this triangle, okay, what is beta? This is A1 B1, clear? Upon this F. Tan beta is opposite upon adjacent. So it will be equal to A1 B1 upon what is this? FE. Clear? Upon when I take this as alpha, let's take this triangle. Okay, and this angle is alpha. So again, tan alpha is equal to A1 B1 upon FO. Okay, so actually when this angle are very small, tan alpha equal to alpha and tan beta equal to beta. So this will be equal to A1 B1 upon FO, and this will be A1 B1 upon FE. So I get magnification equal to FO upon FE. This will get cancelled. FO will go in the numerator. Magnification of telescope is the ratio of focal length of objective lens to the focal length of eyepiece. Yeah. So if we want higher magnification, the focal length of eyepiece must be higher and the sorry objective focal length of objective must be higher and focal length of eyepiece must be lesser. Here FO plus FE. This is called the optical length. Optical length L will be equal to FO plus FE, right? So the length of telescope must be equal to this or greater, right? It cannot be less than this FO plus FE. This is the optical length. The formula for magnification FO by FE, right? So just note down this derivation for magnification of astronomical telescope. Now, some important points related to astronomical telescope. Now, see, light gathering power and resolving power, these are very important parameters for astronomical telescope. Light gathering power means amount of light entering through the objective lens, and that is directly proportional to the square of diameter of objective lens. So that is the reason to increase the light gathering power, the diameter of objective lens must be kept higher. And higher the amount of light is entering through the objective, higher will be the resolving power. Okay, now next, the rays of the object are refracted by objective lens. See, in the example of which we have taken about the astronomical telescope, we have seen that the rays of the object are refracted. So such type of telescope is called refractive telescope, right? When the rays of the object are refracted through the lens. Such type of telescope is refractive telescope. But the limitation is the image obtained is inverted. We had seen in the figure that the image obtained was inverted. So to get rid of that limitation, we can use inverting lens. So inverting lens is used in terrestrial telescope to get an erect image. Clear? Okay. Now, for better resolution, now meaning of resolution, right? If two distinct objects can be clearly seen separated, if two distinct objects can be clearly seen distinctly, then we will say that it is having higher resolution. Means if the image of both the object merge with each other, let's say the boundary of both the images merge with each other, then we will say that its resolving power is less. But if two distinct objects are clearly seen separated, then that is of higher resolution. So to improve the resolution and magnification, mirrors can be used. Now, as these mirrors will be reflecting the light rays, so such type of telescope is called reflecting telescope. See now, here you see this as a primary concave parabolic mirror. and this is the secondary convex mirror. So what happens when light is coming in this way? It will undergo reflection when when it is incident on this concave mirror. Okay, both are reflected. Now again they are incident on convex mirror, and here it is the focal length. So again reflected, and this is observed in the eyepiece. Right? So to improve the resolution and magnification, mirrors can be used, and such type of telescope is called reflecting telescope. Yeah, so just note down these important points. Okay, students, so that's it for today. Here we complete the chapter number 9, that is ray optics and optical instrument. In our next video lecture, we'll start with another chapter. Thank you.